Okay, hello everybody. Unfortunately, the recording yesterday did not come through, and so what I'm going to do is just walk through what we did yesterday, which is we worked on the project together. So I do realize that 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 we did walk through everything. But what I'm going to do is, like I said, I'm going to show you how to enter the data for each of these data sets, and then how to conduct the statistical analysis and how to write everything up. So yesterday we took probably the majority of the time to do this, but today hopefully I'll be able to move through it pretty quickly. And of course you want to be able to hear the questions that were asked for by the students that were there, but I will try to address those as we go through, because I remember most of the questions, so I'll try and address those like throughout while I'm talking. Okay, so the first thing that you need is SPSS. So if you do not have SPSS, you need to download that. I mentioned last week that that's really important to have so that we're not, having to try and get the technology on some of the computers that may or may not be able to access SPSS. So if you don't have it yet, stop the video and go get it, because you are going to need this to do this. Okay, so the first thing I want to show and talk about is the actual assignment. So we have project 3, all right, this is your benchmark project. And this is actually located in Loud Cloud, I believe not in the announcements, but in Loud Cloud. So you need to pull that up, and there is one adjustment that I need you to make. So once you pull that up, there'll be, I believe, 6 different options. I'm sorry, 6 different problems, and the only ones we're going to do are 1, 2, and 3. So you can actually just delete the rest of them and just make sure you keep 1, 2, and 3. Okay, so let's look at the directions first. So answer each question completely. Copy and paste the SPSS output into the Word document for the calculation portion of the problems and highlight the correct answers. Please remember to answer the questions. You must interpret the SPSS output. So let's take a look at this first question. So a researcher is interested to learn if there's a linear relationship between the hours in a week spent exercising and a person's self-satisfaction or life satisfaction. The researchers collected the following data from a random sample, which included the number of hours spent exercising in a week, and a ranking of life satisfaction from 1 to 0, 1 being the lowest and 10 the highest. So we're looking for a linear relationship. So in other words, we're looking for a correlation. And the correlation, we did the lecture a few days ago, and I posted the correlation lecture on an announcement. So if you were not here, please be sure to watch that lecture, because it's short. It's just the concepts of correlation, but you are going to encounter that when you go to take your test. Okay, so we have all the participants, so there's 20, so we have an N of 20, and each participant is measured on how many hours of exercise they do per week, and then they're given a survey on how satisfied with their life they are. So we want to see if there's a correlation here. So keep in mind, not a causation, but a correlation. So it doesn't mean that hours of exercise actually causes life satisfaction, or life satisfaction causes you know, how much you exercise. I am just wanting to find an association between these two. Okay, so the next thing I'm gonna do is pull up my SPSS. Okay, so this is the first window that you should get. So when you get the, yeah, so when you pull up, you'll get your app for SPSS, you will want to click on new data. And once you click on new data, you're going to get something that looks like this. Okay, so this is our data view. So this is where we're going to type in all our data. So we click down here on the blue, okay, and it says variable view. So we'll click on that. Now this is how we set up our variables. So our variables are life satisfaction and number of hours spent exercising per week. So the numbers on the side indicate the participants, all right? So we have to indicate the number of hours, okay, as a variable. So SPSS can be a little tricky. There's some values or symbols they don't accept. So I am going to put just hours. That is something that I can look at and know what I mean. If you would like to extend that and be more descriptive, that's fine. If you're kind of going to, you know, feel a little bit confused about what variables are what variables, you can put hours exercising. Okay, so, you know, you could do something like this. All right, so you kind of know more, remember what the variable is. So then if I just click on type, or I can click enter, so I'm going to get all of these values here, and actually you don't need to do anything. So this is a correlation, so we're not trying to divide into groups. We're just looking at observing the data that exist. So my second is life satisfaction. Let's see, I'm just going to go ahead and do life satisfaction. Again, you can write whatever you want to write depending on your what makes most sense to you. And then, oops. Okay, and so then we're going to go ahead and click, and you'll see that all of this, the width, the decimals, decimals are, you know, how many decimals how many values past the decimal. So in this case, it's 2. We can always change that, but we'll just keep that at 2 for now. And the rest is really not what you need to worry about. So now we have the variables entered in variable view. So we're going to go down to data view. Okay, and so this is where we're going to enter all the data. So let's jump back to our data. Okay. So we're going to take hours of exercise, and we're just going to copy and paste all of those data. I'm just going to copy, okay, and then I'm going to go back to my SPSS, okay, and I'm just going to copy. I'm going to paste all the data there. Okay, so I'm going to jump back then to my assignment or the data that's presented here, and I'm going to go to the next variable, which is life satisfaction. I'm going to copy and paste that, and then again jump back to my SPSS. Okay, and I'm going to just paste all of this, the data in there. So setting up a correlation in SPSS is relatively simple. There's no other real, real manipulations that we need to do. So what we do now Even though there's so many options in SPSS. What we're gonna do now is go to Analyze. So go to Analyze. If you recall, the first two questions on this on number one was regarding descriptive statistics. So I am actually going to go to descriptives, and I'm gonna, descriptive statistics and then to descriptives. And then, let's see, I'm gonna pull this over for you. Okay, so then I'm gonna get a window that looks like this. And I'm gonna take hours exercise, that's our variable. Life satisfaction, click that over, that's our variable. And I'm gonna go ahead and look at options. I don't know if I'm actually going to need, looking at, okay, so we want a mean, we want the standard deviation, and we want the variance, okay? We're not caring about the range too much, which is really the minimum and maximum number, although if you were doing this for real, it might be kind of interesting. I'm going to try and create tables that are as simple as possible. So all I want is the mean, standard deviation, and variance. So I'm going to click on continue, and then I'm going to click on OK. And so I'm going to get a nice little box that says descriptive statistics. Okay, and so now I can see that the mean for the mean hours exercise is 8.8, and the score on life satisfaction is 5.05. So what we're doing is to see if there's a correlation between these two variables. In the next step, we have our standard deviation for our hours exercise and our variance. So that's exactly what we need to do, what we're asked for the first two sub questions for number one. So what I'm going to do, I'm just going to go ahead and copy this. So all you need to do is copy, and by the way, this is called output. So you have the data that you enter, you analyze it, and this is what the results that you get, right? So I'm going to copy this box, and I'm going to go to, let's go back to here. I'm going to go to my, yes, this is it. I'm going to go back to my paper. And so these are the sub questions. Find the mean hours of exercise per week. Oh, I'm sorry, hold on one second. I'm gonna paste, I forgot that I was gonna paste this. So I'm gonna go ahead and paste this. Okay, so it looks like this. And I've already done that, so I'm just gonna show you. So I included the minimum and maximum here. Again, you're not gonna need to worry about that. If you do include it, no big deal. But what I'm really interested is the mean, the standard deviation, and the variance. So I am just going to write out the mean, write out the variance, okay, and the standard deviation, which is in this particular, table, okay? Now, one thing that I would really like you to do is make sure that you highlight the answers. Now, I had some questions yesterday as far as, well, what exactly do you want? Last time, it doesn't matter, as long as you highlight them, or if you put them in different font, that's fine. Because these have separate separate questions, for this one, go ahead and write these right by the questions, okay? Because they're not only looking for an interpretation, they want just to know that you know where to find the means and the standard deviation when you're using descriptive statistics in SPSS. So I just wrote the variance and the standard deviation, okay? Now we're gonna go back and we're going to run a correlation. Okay, so we're gonna go back and we're going to analyze, and we're gonna go down to correlate, and then we're gonna click on bivariate. So let me go do that again. So we're going back to our data, we're gonna go to analyze, we're gonna go all the way to correlate, and then to bivariate. Okay, bivariate because it means we just have two variables. Click on that, and I'm going to get a window like this. Okay, so once again, I'm going to take each of these variables and click them over into variable box. I'm going to be using a Pearson correlation coefficient, and I'm going to now go to options. Okay, so my options look like this. Well, I'm going to include means and standard deviations. I don't really need that because I already have my descriptives. I'm just gonna go ahead and include it in K, and just because. Okay, so everything else should be set. There's a lot of things in SPSS. There's a lot of different options, so that tends to overwhelm people a little. Don't let that do that. For this assignment, I am going to just keep it as simple as I can. So we're going to continue there, and then we're going to continue here by clicking OK. And then we're going to get on our output, we're going to get our correlation table. Okay, and this is our correlation table. So if we just take a look, if you look at the correlation coefficient, which is the Pearson, it would be right here, right? So this is the actual, and maybe I need to highlight this, I don't know. This is the actual, 1 second. Okay, so this is the Pearson correlation coefficient, all right? And as was mentioned in the correlation lecture, we have a negative direction and we have a pretty low correlation, all right? So remember that our correlation coefficients are, go from -1 to negative or to +1. So our correlation coefficients are only in between -1 and +1 because we can only have at the highest limit a perfect positive correlation, the lowest limit a perfect negative correlation, and just everything in between. It tells us the strength of the correlations, right? So this is a negative 0.103. So it's essentially 0, okay, because it's going to fall kind of right in here. So 0, if 0 is right here, okay, 0 indicates no correlation or no relationship. Another way that we can start interpreting and understanding what our data tell us is by looking at the significance level. And the significance level is 0.664. So remember, we are always setting our significance level at 0.05. Okay, and so the question is our significant level here, is it greater than, or I guess, or you can even say greater than, or is it less than 0.05? Okay, meaning that if it's greater than 0.05, then that's in the critical value. We're just going to go ahead and assume normality. Okay, so if we have a value, whatever the value is, remember, because we're going to have to take 0.05, we're going to have to consult a table, we're going to have to look at the critical value and set that right here, right? So the critical value is here and here, and so we're going to find and see if RF correlation falls into beyond 0.05 in either end, and it definitely does not. It's 0.664. It's very far from the, or sorry, I should say close to the distribution. It's far from the ends of the critical region, which is where we'd like them to be. So that's how we read that. Okay, so what I'm going to do is I'm going to calculate, I'm going to go back here. I'm going to copy and paste this into my document. Okay. So I'm going to copy and paste my correlations. Okay, and this is what it should look like. Again, I'm looking at negative 0.103 and 0.664. So I'm looking at both of those values. And then I've run the bivariate correlation and I'm looking to see if there's a relationship. Well, clearly there isn't. So I'm going to report that there is no significant correlation between hours of exercise per week and life satisfaction. Don't forget the statistical values. In this case, our R symbolizes the Pearson correlation coefficient. And so our test statistic is R is negative 1.03, and our p-value is greater than 0.05, which once again tells us that we actually had a greater than 5% chance of committing a type 1 error. Okay, so that's what you do for number 1. Duh. And I put that down here. Again, if you can, let's see if I can copy this. Oops. If you can put it up here just for this one, that would be helpful because, yeah, there we go. For me, just when I'm going to grade it, all right, for number 1. Okay, most of the questions yesterday based on this were more formatting questions. So kind of asking, well, where do you want everything? And, you know, is it okay? Do we have to put the results down here, up here? So, you know, the thing is, as long as you are able to answer the questions, do you know where the mean is? Do you know what the standard deviation is? Do you know what the variance is? Can you interpret the results? Okay, can you interpret your data? Can you interpret if there is a relationship? Okay, so let's go down to the next one. So number 2 says, insomnia has become an epidemic in the United States. Most research has been done in the development of new pharmaceuticals to aid those who suffer from insomnia. Alternatives to the pharmaceuticals are being sought by sufferers. A new relaxation technique has been tested to see if it is effective in training the disorder. 60 insomnia sufferers between the ages of 18 to 40 with no underlying health conditions volunteered to participate in a clinical trial. They were randomly assigned to either receive the relaxation treatment or receive a proven pharmaceutical treatment. 30 were assigned to each group, and the amount of time it took for each of them to fall asleep was measured and recorded. The data are shown below. So it wants you to run an independent samples t-test or a independent one sample t-test. Okay. Oh, sorry. 2 samples t-test, excuse me, to determine if the relaxation treatment is more effective than the pharmaceutical treatment, using a level of 0.05 for the significance. And then, so what you need to do, and this is kind of like the final instruction, you're going to use those data, interpret those data, and report the test statistic using formatting criteria through APA. All right, so let's go back to SPSS. There's a little bit different way of entering data here because it is an experimental study where there are independent variables and dependent variables that we're using, right? So we're trying to get looking at independent variables, the ones that we actually can manipulate, and seeing if there's an effect on, let's see, effect on insomnia. Okay. All right, so I had a question about this too. So there's one of two things that you can do. One thing is, because we already did this, you can go ahead, you can delete all of these data, all right? But I would not suggest that. And the reason why is that if there is like maybe a little snafu or a technical glitch, you know, it's good to have these here. It's good to have the output, all right? So what I like to do is just, I'll keep this data, I'll keep this output. I'm gonna just start fresh with a new one. Let's see, it's gonna let me do that. Oh, there we go, it's hidden. Okay. All right, so once again, this gives us the data view, all of us up front. We're gonna click on the variable view and we're gonna enter our variables. All right, so our variables, okay, are the people who received one, the relaxation treatment, and two, the people who received the pharmaceutical treatment, right? So the way we have to go about this is we're dividing it into two groups, but we're not dividing it by column. We're dividing it by sort of by row. So this is, follow along with me here. So if this is the relaxation technique, I'm just going to put relax. I'm able to put relaxation, but this is the relaxation technique, all right? So you don't need to do anything with any of these except for values. There we go, okay. Values, all right, so click on values, and I'm just gonna arbitrarily assign a value to the variable relaxation. Okay, why do I need to do this? Well, two reasons. One is that SPSS does not accept non-value numbers, so they, you can't use discrete variables. So you need to use numeric variables. If you use discrete variables, then you would have to code those, especially, and assign values. All right. So in this case, we're assigning a value to that will indicate the relaxation. So who is in the relaxation group? What differentiates the relaxation group from the pharmaceutical group? Otherwise, SPSS is not going to know which is the differentiation. So we need to give, I'm just going to say 2 for value. The other one was the pharmaceutical group. And that's just how I am going to label these. So then I'm going to click okay, right, and let's, oh, you know what, I'm sorry, there's one thing I need to do that's different. So instead of putting relaxation, I'm going to go back, because we do have groups. We're going to divide the groups, but sort of in a different way. So I'm going to change my independent variable to group. Okay. Okay, so now that I've done that, I can go back to my data view, and so I see group. Now, since I've assigned a value or number that's different, that differentiates the groups, I know that now I can actually show SPSS what the groups are, how they're divided. All right, and so I'm going to take one. So what is this, 60? So we have an N of 60. So we know 30 we're in the relaxation group, which is a value of 1. So I'm just going to go down here and I'm going to type in 1, 1, 1, 1, all the way down to 30. Okay, so that indicates to SPSS that the relaxation group was all the 1s. Now my second group was the pharmaceutical. And so I'm going to assign 2 to the rest, to the other half of the participants. So of course, I'm going to go all the way down to 60, the 2. Okay. So now I have divided group 1 and group 2, and so I need to enter the variables. Okay, so I need to enter the dependent variable. Now, let's go back. All right, so we have group. The next variable that we need is, I'm going to go ahead and say the treatment. Okay. Okay. We don't need a value because it's just going to be one variable. All right. So then we go back to data view and we're going to go to treatment. And if we look back on our form here, here are our data. Okay. So we're going to just copy and paste the relaxation group data. And we're going to jump back into our oops, sorry, that was the last one. Let me go back into this. I just click that one. Okay, so our treatment, all right. So this is the dependent variable and how they scored on it. Okay, so how do they score on the independent variable? Well, the first group, let's go ahead and paste that information. Okay, so we're going to go back into the project. Oops, sorry. We're going to go back into, I keep forgetting which is which. Once again, one more time. And we're going to go to the pharmaceutical group. We're going to copy and paste. We'll copy, and then we're going to go back and just paste, because this is the second group. This is the pharmaceutical group data. So we're going to just paste that there. Okay. So now we have all of our data in here, and SPSS is able to know which group is which and how each group scored. Okay. So now it's time for our analysis. So there's a few ways to do this. I think this is what I'm going to do first. Well, as you can see, hold on, let me see. As you can see, there are several options for analyses that compare means. All right. So we have a one sample T, we have an independent samples T, paired samples T, and then a one-way ANOVA. So we've done this one, and this one in class. All right. So we can go ahead. Let's click on independent samples T. All right. So when we click on that one, we're going to get a window like this. We have our two variables. So our group and our treatment. So our group is going to be our grouping variable. So I'm going to click on group and then click on grouping variable. The treatment is the treatment data are the test variables, the dependent variables. So if I highlight the grouping variable, you can see that there's question marks. So they just need to make sure that we are consistent with our value. So group 1, we gave 1, group 2 value was 2. So we define the groups. Now let's look at our options. All right. So our options here, not really important. So the confidence interval percentage, excluding certain cases, these are all things that we would do if we have like missing values. So in this case, we don't. So we're gonna go ahead and continue. And then we're gonna just click OK right here. Okay, and so I want to take a look at the differences. I'm sorry, I want to take a look at what this says. Okay. All right, so here's a little conceptual stuff for you. When we run an independent samples t-test, we're comparing two groups, right? And maybe we should actually rename it as two sample independent, or independent two sample t-test, because there was two groups. But look at this, there's an F, okay? Now an F ratio is a measure of the analysis of variance. When you think about it though, the F ratio measures between subject differences, or between treatment group differences, which is exactly what we're measuring with the T statistic, except the difference is that the F statistic can measure more than two groups, or two or more groups. The T statistic is stuck with just two groups. Okay, so instead of doing this, oops, can I get this smaller? Yeah, so instead of doing this, I'm going to actually run another test. It's going to give me a little more information. Specifically, it's going to give me an F. So just keep this here. Don't worry about what's on the output. The output's going to look a little messy, and that's okay. It always does, whatever research you're doing. So let's go back to analyze. So all we have to do is go up to analyze. Okay, and then we're going to go to actually something called general linear model. So just models that show, you know, like a one-way difference between group 1 and group 2, or group 2 and group 3. But in this case, group 1 and group 2. So let's go to univariate. We only have one independent variable. And we're going to get kind of a similar window. So our dependent variable is our treatment. Our fixed factors are our group, right? Because that's what we manipulated, or sorry, that's the group we have 30 in each, right? So that's fixed. So let's go down to options. And this is where we can click what we want. So we can click our descriptives. May as well click descriptives again. We can also click estimates of effect size. That's really what I want here, all right? Don't worry about heteroscedasticity. This is something a little more advanced. This is already set. The significance level is already set at 0.05. So at the very bottom, we can go ahead and click continue. And we get back to this original window, and we can click OK. So then we're going to get another, another table. Now, this looks a lot like an F ratio, all right? Do you guys remember, this is an F ratio. Do you guys remember that our F ratio is literally, it's looking at the same thing. I guess I've mentioned that already, right? It's looking at the same thing as the t-test. It just is, when it's reported, it also gives you a nice, the significance and our adjusted R squared, which is our effect size. Okay, so if you look up at independent sample, let me see if I can do this. Okay, there we go. So if we look at under the independent samples box that we use to analyze these data, we have the T. Okay, so that's good. This is our T statistic. all right? We have our degrees of freedom. So if you remember, when we calculate a two-sample independent t-test, we actually take the n of the entire group. So how many people actually participated? We take that minus 2, all right? So we take n minus 2 because we have two groups. And so 60 was our n, and so 60 minus 2 is 58. So another really important thing is to look at the significance. In fact, as a researcher, that's, when you get output, that's the first thing we tend to look at is 0.016. Is that going to be greater than 0.05? In other words, too, we can use our we can use we can use our t-distribution table, right? And so we go back to the independent t-test, two-sample t-test chapter or the lecture, and that's going to be 0.016 as a significance. So that's going to end up being our p-value. So if we look at the t-distribution table, we can see that our using the degrees of freedom, we can see that we're going to set once again, right? We're going to set a test, a 1 or 2 tail test, and use the degrees of freedom to find the corresponding critical t value. All right, so whatever that might be. Okay, but at the end of the day, what we're going to look at as far as this, the output is the significance. So if our significance is less than 0.05, then we're going to be able to say, well, we had less than 0.05 probability of committing a type 1 error. This is what we look at usually first, okay? Then these kind of come into play, but my significance level is most important when I'm interpreting how my data turned out. Okay, so if we scroll down, we gotta go back to this. All right, if we scroll down to here, oops, and we ran a univariate analysis of variance. So, excuse me, we used the same data, right? And the descriptors are the same, but this is the test that we ran. Now, the only reason I wanted to use this was to find the eta squared or the r squared, however your book says eta squared is fine, but it's really the same thing. So I want to know the effect size, and if I look down at the adjusted r squared, then that's actually what I want. It's adjusted. It sort of is not biased towards error. It accounts for a certain amount of error. So we're going to use that. Okay, so then we're going to copy and paste this box. If you want to copy and paste this, feel free. This is the one that I'm really, oh, I'm sorry, you know what? This one is the one that I'm really interested in, the independent samples t-test. All right, so I'm going to copy this, and I am going to paste that into my project, right? And so I did this earlier. Okay, I did include this group statistics, all right, which means descriptive stats. And then I posted my independent sample t-test here. And so, again, you can ignore the F for now, but we have the T, we have the degrees of freedom, we have significance, and that's pretty much all we need. We have R squared as well. So the result would be that the relaxation treatment is significantly less effective than the pharmaceutical treatment, which is what I wanted to find out to begin with, right? I wanted to find out if the treatment is more or less effective. Essentially, it's actually less effective. And so I'm going to write my T statistic. In parentheses, I have my degrees of freedom. I have the actual T value here. P-value was less than 0.05, and my R-squared is 0.08, okay? And this means that only 8% of the 8% of the treatments actually had any effect on insomnia, okay? There were a lot of other factors involved. Okay, and then the last one is an analysis of variance. How do I know? Because there's more than 2 groups. So let's read this. So a researcher is interested to learn if the level of interaction a woman in her 20s has with her mother influences her life satisfaction ratings. Below is a list of women who fit into each of 4 levels of interaction. Conduct a one-way ANOVA on the data to determine if there are differences between groups. In other words, does the level of interaction influence women's ratings of life satisfaction? Report the results of the one-way ANOVA. If significance is found, run the appropriate post hoc test and report between what levels the significant differences were found. All right, so here's a thing with that, is that we actually are not going to talk about, and we didn't look at the post hoc test. In a nutshell, what the post hoc tests do is, if there are significant, if we find between treatment differences, a post hoc test will actually tell us what particular differences were significant. All right, so it's really important, but I'm just gonna cross this out because I think that it can be a little misleading if it is still in there. All right, so I'm gonna cross that guy out. So what they want us to do is, once again, report the test statistic using the APA formatting and interpret the results. We're just gonna make that little statement that we did in the independent 2-sample t-test above. Okay, so we have no interaction, low interaction, moderate interaction, and high interaction. These scores are scores of life satisfaction. All right, so let's set up our data. All right, so once again, I am just going to create a new data set. It's going to increase the amount of stuff on my output, but that's okay, as long as it's still there and we haven't lost it. So let's kick this off. All right, so we're going to set this up pretty similar to before. We have the groups that we're going to divide up into 4 groups. And then we have the treatments. So the differentiation between or among the treatments. So just like before, we're going to go to values for the groups, and we're going to divide the groups. We're going to symbolize them by numbers. So for the first group, it's going to be 1, right? So the label was no. I would put none, but if you want to be a little more descriptive, you can say like no interaction, however you want to do it. And then I'm going to add those. The 2 was low interaction. You can write whatever you want that makes sense to you. Number 3 was moderate. Number 4 was high. I'm going to add all those, and then I'm going to click on OK. Now SPSS knows that I have divided everything into 4 groups, and it knows how to differentiate those groups because of the values that I assigned. Right? So then I'm going to go back to data view. Right? and each group had 10 participants. So I'm just going to go down the line, and the first was the no interaction. So I'm going to just one, 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 one. And then the next group was low interaction. So two, 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 two. Mm-hmm. And then the third group was the moderate interaction. Let's minus 10. And then the last group was the high moderation, which is signified by 4. And that will go all the way down to 40 because we know there's 10 in each group. Okay, so now SPSS knows which groups are what. So the treatment is already divided up. We already know which group is what. So now we just have to enter these scores themselves. So that means we have to go back to our data, and the no interaction group, like before, I'm just going to copy and go back to this. And paste. Okay. And then for the next one, let's go back to the data, low interaction. Copy. And go to the data again. And paste. And we'll just continue to do this. Going back to get our data. Oh, no, sorry. And our last set is going to be our fourth group, the high interaction group. Okay, so now we have all of our data. Everything is set and ready to analyze. So we're going to go back to analyze, and we're comparing means, right? But and we could even do a one-way ANOVA here. But we're going to go to the general linear model. That will give us a little bit more information, including our eta squared or our r squared, which is the effect size. So let's go ahead and do univariate. Once again, this should look familiar. So our groups are our fixed factors, our treatments, and the scores for each treatment is the dependent variable. Let's go to options. Let's go ahead and get descriptives. We definitely want to get effect size. We don't need to get any of this. Significance level is already set at 0.05. So then we can continue on with that. And I think that's about all that we need. So let's click OK. And so click on OK. And okay, so this is the analysis of variance. So we're going to get between subject factors. All right, so that's just sort of how we divided up the groups. We have our descriptive. So for each group, we have the mean and the standard deviation. And this is the actual test. So we want to look at the corrected model. Okay, so the corrected model at the very top. All right, so we want to look at the corrected model, and this will give us the information we need. So our degrees of freedom for our between subject effects or between group differences is 3. Okay. And between, within group differences is error. Okay, so once again, I'm just going to put B, degrees of freedom between, and the degrees of freedom within, because within is always error. So if we just kind of can jump over to the F ratio, 1.570. All right, so 1.570 for an F ratio. What does that mean? Where the F ratio, null hypothesis is not 1, or it's not 0, it's 1. Okay, and so we are going to use our, well, we would use our F. Oh, I'm sorry, I think you do have an F distribution table. Yeah, you have an F ratio distribution table. So we're going to use our degrees of freedom to find our critical value, and whatever that critical value is, we're going to find out if our F ratio is going to fall in that area. Now, you don't have, before looking at the F ratio, okay, the first thing as researchers that we look at is the significance. So again, this is the question, is 0.213 greater than 0.05? And if it is, that means that it is going to, not going to be in the critical region. Okay, we want our significant level, or alpha level, or our p-value to be 0.05 or less than. Okay, so we kind of know that already. We have a low F value, so we know that that's probably not going to be the significant, because if 1 is the null hypothesis and this is only 1.5, then probably our mean, or our, sorry, F ratio is going to fall like right here. So that's close to the mean. That is definitely not what we want. So, so no, already we know, okay, this is not good. So what we do though, oh, and let's look at this before, the adjusted R squared. All right, we're looking at that 0.042. So basically 4% of our treatment had to do, or had influenced or accounted for any kind of between subject effects, any kind of significance. But the problem is there really wasn't any differences, statistically speaking. All right, but because there probably are some differences, okay, and we kind of can see this right here. There are some differences that we can calculate the R squared and see that, okay, yeah, that makes sense. It's a very, very small R squared. Okay, so I'm going to, I don't feel the need to copy and paste descriptive stats. You can if you want. I think maybe I did on the example, but it's up to you. This is what I'm really most interested in. So I'm going to copy, and then I'm actually, let me do this real quick. Just, I want to make sure that it's, oops, clear all drawings. Okay, so I'm going to copy this. Okay, go back to my assignment. And I'm going to, I did do the descriptives, but again, you don't need to. I'm going to paste that into the test of between subject effects, or into the assignment. One little thing, and you probably figured this out already, but one little minor suggestion is that when you paste, use this. Because if you use any of these, you're going to get some kind of wonky numbers all over the place without grids or tables. So use this paste option right here. Okay. So then what the question, the answer to the question would be no significant mean differences. The F ratio is 1.570. So don't forget to put the degrees of freedom in parentheses here, the between degrees of freedom, and then the within degrees of freedom in that order. Our p-value is actually going to be greater than 0.05 because we did not find a significant effect. And then our R-squared is 0.042, which, like I said before, is a very low effect size. Okay, so that is it for the assignment. So essentially, if you've done all of this work that I walked you through, then you are ready to submit it. Okay, to submit it to LoudCloud. If you have any questions, you can always let me know. You will not be using SPSS for your test, but you will be having to interpret results from a hypothesis test. So make sure that you can understand. I guess my best suggestion to you is to understand where you got this information, okay, and understand, for example, what does this, how do we know about this? What does this mean? Can you interpret? If I said we had, a correlation of -1.03, here's an option of 4 different scatter plots. Which one is more appropriate to having a correlation of -1.03? Okay. And same thing with all these. You might have to interpret, giving some numbers. You'll have to probably, you're going to have to do some calculations and come up with either a result like this, or be able to interpret some things from partial calculations. And then the last one, same type of thing. All right. So I posted a study guide. I've posted the correlation lecture, the independent 2-sample T lecture, I think is the same thing as the 1-sample T lecture, and the ANOVA lecture. And I have lots of things included to use as resources to help you study for the test. Put them all in an announcement and make sure that you have that. Okay, so the test is open. It's ready for you to take it, and there's a lot of instructions, so make sure you follow those. And you will have till the 26th at 11:59 p.m. But once you sit down and take the test, you will just have 2 hours. Okay, you can't keep coming back and forth within like days and throughout like one day or something. So make sure you're ready when you sit down and take it. Okay, and that is it. So this will probably be really helpful for those of you who are not in class the other day. If you are in class the other day, then this might be a good review. Okay, so stay safe, have a good one, and good luck studying for all your tests and getting your final projects and everything done.